Okay, and thanks again for joining today's session for understanding the value of IEC 61508 product certification. My name is Ted Stewart. I am the Program Development and Compliance Manager here with exida. I wear many different hats. I work as the manager of the OEM Product Certification Group, which we'll be speaking about today. I also assist the end user business, help manage the C4C program, and I also am the Deputy Quality Manager mainly when it comes to ANSI when we get accredited and we have our audits every single year. My area of expertise is in safety and high availability automation systems. My previous jobs were all in manufacturing for Lockheed Martin and Harris Corporation, and I'm a big fan of lean process improvement. Seeing the attendee list, as always, we want to do a little bit of background information about the company before we get into the core information today. Just to recap, we are a worldwide global company. No matter where you are today in the world, we do have a little red dot that is close to your home, and we're rapidly growing. exida Japan is one of our newer locations, and it's doing phenomenal. Another great little bit of information is I am in the brand new sound booth. An initiative for 2016 is a lot of online training, so we have its own sound booth. We also expanded our company to a new building that's 3 to 4x in the original size of the previous building. So a lot of great stuff at exida. We're very excited, and we're doing very well. exida is involved with the complete supply chain of functional safety in multiple industry sectors, anywhere from the original equipment manufacturer who required the product certification all the way to the end users that use the product. Now, exida, we do provide software tools, training, consulting, and procedures related to functional safety, security, and reliability. And you'll see here are our main suite, our main products, and 6 different categories. The first one's consulting. We do end user work for process safety, normally to IEC 61511. We also work in 62061, which is machinery, and also ISO 26262, which is automotive. You'll see we also do alarm management and cybersecurity. Next, you see we have engineering tools. The main tool that everyone loves is Excellentia. This tool just makes everyone's life easier, including ours. Not so much manual labor anymore. Now you can just enter your numbers and have the software do the work for you to minimize any errors. You'll see here we have a whole slew of different products and tools that we can offer. And then today's webinar will be on the product certification, the IEC 61508 certification. We have cybersecurity certification as well. Next, you'll see in training, we basically offer training somewhere in the world at least once a week. So, and trainings will be increasing more and more. One of the biggest initiatives for us, like I said, is now that we do have a sound room, we will be working on online training, which is very exciting to help those who aren't able to travel across the world or travel to a different state to sit in live. Obviously, I believe live training is, and in-person training is the best training that you could get. However, if you're not in a situation and you can't spend a week out somewhere training, then this is the next best step, and so we're helping fill that void. Reference material, the best thing with exida that we like to do is we like to publish everything we know, and we'd like to be that open book. So if we're learning something new and it will help you and improve your safety, we're going to publish it. That way you can get your hands on it. We don't want to keep any secrets. We have our big database, we have tutorials, we have textbooks, reference materials, market studies, and each year we're just going to keep writing and keep writing and keep writing to help and improve everybody's system to make the world a safer place. And then of course we do have personnel certification like the CFSE and CFSP program. Recently we've added the CACE and CACS, which is for cybersecurity. If you aren't aware, that's one of our the newer certifications. And then of course you can get certified in automotive and hardware and machinery. The most popular is in process, and then also software. Okay, let's start learning about functional safety and product certification, and why is product certification so important? Functional safety. Well, before I get going, I do want to say, because I do see 1 or 2 questions already coming in. Excuse me. we're going to answer all the questions at the end. I'm going to go ahead and quickly go through this presentation to allow for more time at the end for questions. So I'm not ignoring you. If you do use your question pane there, go ahead and type them in, and I'll get those answered at the end. All right, functional safety goal. The automatic safety function will perform the intended function correctly, or the system will fail in a predictable, safe manner. And that's the objective, is when something does fail, because everything will fail in life. It's just a matter of when. And when it does fail, what kind of impact does it have? Is it a catastrophe, which is horrible because accidents do happen? No, or is it going to fail in a way that won't impact anybody? And so that's the biggest goal of functional safety. So you want to perform the intended function correctly, which is your reliability engineering, and then you want it to fail in a predictable manner, which is your safety engineering. Now, how would those writing the standard create these requirements to reach such a goal? Where would you start? What needs to be considered? And if any of you haven't seen IEC 61508 standard, it's quite big, and it's an undertaking to learn and understand the standard. But that's what we're here for. So you'll see here in front of you, there's two fundamentally different issues. You have systematic failures, including design faults, document errors, and lack of training competency. And then you also have your random failures, which are more commonly in hardware reliability. Now, IEC 61508, the basic safety publication, this is an internationally performance-based standard for all industries, so it's a global standard that's recognized all over the world. It's large, it's complex. It was written for a bespoke system, which is basically a turnkey system. Now, there are hundreds of requirements in parts 1 through 3 which are written to achieve the functional safety goals of reducing both random and also systematic failures. With this level of complexity, many safety critical automation system users wanted the system checked by a team of experts who had the depth of knowledge to understand the details of IEC 61508, and that's where this all got started. We'll speak here. Okay, how did certification programs come to be? Well, functional safety certification programs were pioneered by two TÜV companies in Germany. Okay, this is back in the 90s. They used a different standard at the time. This standard was VDE 0801. Okay, then in the 2000s, IEC 61508 came out, which completed it. It's the national standards were all now replaced by new international standards because functional safety grew so fast. Exida was founded in 1999 by people from both TÜV and also from the industry to give a better certification program, and that's where it all stemmed. So what is certification? All right, and then we'll get more into depth. We'll get examples of why and how product certification will help manufacturers and also end users. Okay, so certification can be what? You can certify systems, you can certify products, components, you can even certify personnel, which is one of the most fastest growing certifications out there. Why? Because many companies see the need to have somebody within their organization be that functional safety expert. And without one, you run higher risk because you don't have anyone in there making sure things run through smoothly like you would a quality manager. All right, so now we have functional safety leaders that are within companies. The certification is a third-party review that's done against a set of requirements, which are now called a scheme per the standard, and these are based primarily on international standards. Functional safety certification involves a detailed analysis of two different things: the engineering process and the design margins, which results in random failure rates in all failure modes. Okay, so it's not just about the PFD average, it's about all the failure modes, whether it's fail safe, fail dangerous, if it's detected, if it's not. All right, and then also, because of the growing need, and I'm sure many of you have seen it from day to day, cybersecurity threats. All right, now cybersecurity certification is also a growing need, which now will involve a detailed analysis of the engineering process cyber defense mechanisms, and a network robustness. Okay, so now that you know kind of what certification is, who does certification? Okay, today, I mean, there's many different certification programs that have been established by many different private companies. Even some governmental bodies all over the world have this. Okay, and all organizations who perform certification should be accredited for their field of work. That's very important because those who have done their research will know which bodies are accredited and which ones are not. And if they're not accredited, that means they follow their own standards, they do what they feel is right, and nobody's there to judge them or to audit them. Okay? So, a certifying body, if they're accredited, they now have to get credited by, in the United States, it would be someone called ANSI, the American National Standards Institute. Okay, it's the United States IEC liaison. However, let's say that's for the United States. But let's say, hey, you know, I got the certification in the U.S. Now, how does it get recognized in Germany? How does it get recognized in the U.K.? Well, ANSI, who's the U.S. liaison, is a member of the IAF, which is the International Accreditation Forum. Most countries around the world are signatories of the AIF, okay, which then create a multilateral recognition arrangement which assures global certificate acceptance around the world. Okay, so that's how it all pulls together. So when someone says, yeah, I'm accredited by ANSI, you don't have to worry. That is now an accreditation around the world. Okay? And if you have more questions, you know, feel free to ask them in the toolbar. Every question that's going to be asked in the first session and in the second session I'll create a spreadsheet with the questions with the answers, so everybody will have every single question, every single answer that was asked on both sessions. I just feel that that's useful, and you'll get that probably next week once everything's finished. So when you're going and you're interviewing, say, a certifying body, if you're a manufacturer or even if you're an end user, when you go to that certifying body, make sure you ask to see the accreditation body logo on the certificate. Okay, because if you do not, then that's called a house certificate, and that means that work was done solely because they felt that's what was right, and they're not being audited. They don't need to keep up with the newest standards, and they just do what they feel is the best. Okay, here, as you see on one of the extra certificates, we are accredited by ANSI. You can see our identification number right there, 1004, and we get audited every single year, and everyone loves getting audited. All right, so the exida scheme. Why do we have a scheme? Well, what happens is when we first got started, you have the standard IEC 61508, right? It's the family of standards. It's the umbrella standard. However, once you get involved with it, once you get involved in functional safety, more and more areas need to be improved that the standard can't touch. Okay, and that's where we've developed an advisory board filled with end users. Okay, and they let us know, hey, look, exida, you know, here's what we see, here's the certification. How do we get reassured about this, or you know, I need these failure rates. How do I have that? Or, you know, this cybersecurity audit. What can you do about that? So what happens is, from the recommendations of the board, exida then has to appease the board, and that's where these extra items come from. And this is why we feel exida, even though we're one of the hardest schemes out there, we're the ones that are ultimately helping the end user to the maximum. We're going to give them everything they could ever want, which will then what for the manufacturers? Will increase the manufacturer's sales, because that end user now has everything they need when that manufacturer gets their product certified from exida. So what are those things here? It's the FMEDA analysis, right? You're going to have the accurate failure mode data based on over 150 billion unit operating hours of field failure data. We're going to publish field failure rates, not just that PFD average that you see from most other certifying bodies. We're going to include the safe failures, the dangerous failures, the detected failures, the non-detected failures, everything. We're going to put everything right there. We're going to have the analysis, the publication of false trip data. I know many of you are very interested in users in the various trip rates, right? Maintainability, the design complexity, cybersecurity audits, which one of the newer things, practical proof test is required Other certifying bodies would just skip that completely. But I always ask people, if you have all these products that are still certified, you put them into a system, but still means absolutely nothing if you don't test it correctly, if it's not in the correct system. And so many people just buy it thinking, oh yeah, I'm still 3 capable now. But no, if you're not using it correctly, you can throw still out the window. Okay, it doesn't mean anything unless you use it correctly, and practical proof testing is required because that's what helps will keep things in line. Okay, you have the surveillance audits. Why do we have surveillance audits? Well, it's once again from our advisory board. What they wanted to make sure, because things change all the time, they want to make sure the products that they're buying, if they're certified in 2000, if they're certified in 2006, they want to make sure if they buy it in 2016, are they still meeting? Is that manufacturer still meeting those requirements to IEC 61508, and are they still following them correctly? Because what's the biggest thing is they could say, hey, I'm doing this, but in reality they might be doing something different. And that's where every 3 years, exida will come through. They'll just verify that they're doing exactly what they said. They'll see that they're doing what they're saying with on-site audits. And then also we can now put that reassurance that everything is good to go and you can move forward. Okay, this next section I want to start talking about. I got 4 examples on why people like to get their products certified. Okay, and it's more than just saying, oh, I'm certified, you know, as a marketing initiative. You know, there's more to it. There's more cost savings involved with the product that goes through certification than the product that doesn't go through certification. And you'll see here I got 2 examples with Dow. Is that in a valuable paper, engineers from Dow, they made a point. They made a point of discovering a flow meter failure in operation where the output was locked. A certification scheme with an FMEA, what would it do for them? Well, this looks at every single failure mode for every single component and will find possible design flaws resulting in a locked output. What does this mean? This basically means, look, you know, when this flow meter failure was in operation and it went to that lockout phase, what if they could have gone back, had an FMEA happen to it, and found this problem before it even happened? When are problems the least expensive? When they're already in production, or when they're still in design mode? When do you want to redesign? When do you want to recall? You know, and so that's the biggest thing, is it's better to find something before units are deployed in the field. And that's from, you know, a manufacturing standpoint, and that's also from an end user standpoint. If an end user buys something assuming it's going to work correctly, and they put it in the field, I mean, how much time and effort are you going to waste if it doesn't work correctly? Here's another example. Engineers from Dow also discovered a hardware and software design faults in a nuclear level sensor. The field failure data convinced the site, okay, to replace a device with a different manufacturer. And I think that's very strong, because according to the data, before they even had to worry about putting this into the field, okay, they ran the field failure data. They found that there was others information out there that was better, and instead of taking that risk, they switched the manufacturer. And that's what a good certification scheme will do. We here at exida, we use something called a safety case, where the hardware and the software design process is reviewed in such an extreme detail using all of the IEC 61508 requirements. And through this process, and in many, many, many different situations, hardware and software design faults have been discovered and have been repaired prior to certification, prior to them deploying anything in the field. Okay? And even if something's in the field, mind you, and they want to get certification, that's still okay. We'll still go through the same rigor. If something is found, wouldn't it be better for the manufacturer to find some before that customer who needs to rely on this product and needs it to work every single time? What if the manufacturer finds something? You can then correctly recall it. There's no catastrophe. Nothing happens. You can switch them out, and at least there you find that savings, and then you have that end user, that customer for life. Here's another example. At final validation testing, an evaluating assessor from a certification body asked to witness a series of tests Okay, what it was going to do is going to verify that all claimed diagnostics were operating. One test failed. It's discovered that the optimizing compiler automatically eliminated the RAM memory test as its algorithm determined that the test had no value. That's very interesting, right? I mean, how would they have noticed this without somebody? Because a lot of people take things for granted. They said, yeah, this is great. But when you get that other set of eyes that comes in, and almost certifying bodies almost look for problems, right? As all auditors, as you know from history, they always look for problems. We do it as well, and we always try and find something so that we can help make that system stronger. So you're not only getting a certification, you're having somebody come in looking for ways that it could fail to help save you in the long run. All right, and so because this was found, the product was redesigned before the production release. And here's a final example. A dangerous failure. It occurred in the final element assembly. The solenoid valve was de-energized, yet the ball valve did not close. Another layer of protection went ahead and shut down the unit. When the final element assembly was tested, after shutdown, it worked perfectly. So basically, to meet IEC 61550 requirements, what do we have to do? All engineering tools must be checked for proper function and qualified for use. So that's it. So for this situation, and you'll see here that I'm going to read, it was discovered that a mechanical CAD tool inserted default tolerances during a tool upgrade. You know, if someone didn't re-look at this, how would they have known this would have happened, right? And so that's what we do. We went in, we looked. We found the tolerances that were set to default. Those tolerances would then cause, what happened, it caused that valve to bind at a high temperature. Long story short, it was corrected, everything was fine, and it worked perfectly. And that end user was a very happy customer because now their system operated correctly. Because I think one of the biggest pains in their side or hurdles that we hear from from the end users, manufacturers, customers, is spurious trips. You know, when something fails and it shouldn't have failed, everything was fine. All that does is create headaches and production loss. So here's just something, when you go out there and you're looking for a certifying body and you need to ask some questions to make sure that who you're getting is what you want and is it worth the value, because everyone charges a different amount, some higher and lower. I think exida, we're not your lowest company. However, we do so much more than most companies. So if it's something where if you want to spend all the time doing the work, that's fine. However, we do most of the work for you so that you can go off do your job, and certification doesn't become a hurdle, doesn't become a headache. It really just becomes something that you just have to let someone else go through and analyze and go through and analyze all of your products. But anyways, so here's some bullet points here. You know, make sure that the good certification scheme, they use a safety case to ensure completeness of the assessment so that they don't miss anything for you. You want someone to carefully examine the entire mechanical, electrical, and software design. You don't want them just going through and just kind of spot checking. You want to make sure they go through everything. All right, you got to look for completeness. You want to make sure correctness. The documentation quality has to be there. There's nothing that they can bypass or miss. Okay, the design process must be documented with checking procedures. Okay, engineering tools and tool upgrades must be qualified. Staff competency must be evaluated and documented. No, they don't need to go and get a CFSE or a TV expert or TV eng, anything like that. They just need to show competency in that specific role that they're working in. If that technician needs to be, you know, certified, or if they need to be skilled in welding, then we need to see that training that has been taken for that individual to meet his job, right? And the other thing that we need to remember is it's very important that you have these design processes, they're documented, but you have to make sure, are they following their processes? Are they going ahead and doing what's on that piece of paper? Okay, and so that's very important as well. Let's move on to the FMEDA. This is done on a hardware designs. It's to identify all potential dangerous failures. Make sure that you know all of your failures, not just your PDF average. User documentation. The safety documentation, excuse me. This is checked to verify that all this safety information is given to the user on a device, much like a safety manual. And then also the periodical surveillance audits. I've touched on this before, but it's really it has to be done to verify that the device is still safe even after, let's say, that product goes through an engineering change, or if it's something where it's You perform an impact analysis. If it's safety related, if it's not safety related, it's still good to have looked at to make sure you're still compliant with IEC 61508. The safety case. Exida, we've always used the safety case approach. As many of you know, and I see a lot of familiar names on this call today, there are so many requirements in IEC 61508. I can't stress that enough. There's hundreds and hundreds of requirements that you need to go through with a fine-tooth comb to make sure you meet every single standard. Because you never know when that one requirement is going to open up a can of something you missed, or a product that, hey, look, we need to redesign this because of this one requirement. And it's to create a stronger, more robust system. Okay, extra requires, what we do is we want to make it public. We want those assessment reports, we want the certificates all on the website. We have a site called SAEL, and this is probably a gold mine to all end users. They now have a place to go to. Not even just our products are certified, but even other certifying bodies. We put those certificates when we get access to them on this website. So now an end user can go to this site, can make sure that they're building the best system possible from all certified products out there. What's very nice for the manufacturers is if your product is on this site, now all of a sudden all of these end users from around the world see your product, can click on the link, can go inside, and when they want to purchase or want more information, they click on a link that goes straight to that manufacturer's site to help them know where to go to buy what they need. Okay, so next, I kind of want to share with you the product certification process. Here's a diagram of what would happen if you're a new customer or returning. If you want to know, okay, what's going to happen if I need to get a product certified? What will go through here? And so you're going to see there's two sides. You got the left side, which is the exida analysis reports, all right, all the way to the left, and all the way to the right, you have the consultants, which is the client documentation. Okay, let's speak about all the way to the left. What these items here are the things that exida are going to do for our customers. Okay, we'll create a gap analysis report. What is that? That is basically when we start the process, we're going to quickly show you, by you supplying all of your documentation, where your gaps lie with the standard. Okay, you need to do this, this, and this, but you're great over here, so let's focus here. So it quickly shows you where to focus all of your time when you're going to do product certification. In parallel, we'll get one of our other engineers to, if you have electrical work, we're going to work on the electrical FMETA. If you have mechanical, we're going to work on the mechanical part of the FMETA. And so that's going to be worked on while we're working on all the other documentation. We're going to go and create a fault injection test list for you, the software HAZOP report, communication safety report. In the meantime, while all these things are being reported and being created, on the far right side, here are some things that we're going to be asking from you, the manufacturer. The FSM plan. Functional safety management plan, the SRS, validation test plan, tool justification. We're going to look for your software process, coding standard. Some of these things, though, if you have a simple mechanical device, you won't need a lot of this documentation, and that's called a Type A, right? But if you have any kind of software, any kind of electronics, that's now called a Type B product, all right? And that's where you need more documentation. So you have the software module test plan, the software integration test plan. Everybody needs to create a safety manual. If you don't know what one of those are, just ask us. We can help you out. Okay, so now you know what's required of each. So now let's go through the process. So you're going to start the process in the middle there. You're going to go to the FMEA, FMEDA. Okay, so while that goes on, we're going to go get the bill of materials. We're going to break everything down to all the way down to the single nut, the single bolt of this device. We're going to break it all the way down and start looking at failures all the way until we make a complete system or a complete element and complete device. In the meantime, we're going to come on site. We're going to perform a gap analysis. We're going to show you where your gaps lie in the standard, all right? Which doesn't mean you fail. It just means now we know where to start. Now we know where to start working on. We're going to perform any kind of training if your organization needs some training. If you don't need the training then. And then after that gets done, we're going to come back and create something called a baseline safety case. The baseline safety case is the very initial phase that basically you do for all your products, right? How do you design a product? How do you validate your test plans? All the initial information. Then, once that's done, then you're going to go into the final safety case, which is your safety manual, all things that are specifically related to that product. Okay, so you got the baseline, you go to the final safety case. By the time you get to final safety case, all the FMETA work's going to be getting completed. Then you're going to get everything audited. We'll have an evaluator doing all the work, and then we have a certifying assessor that then looks over everything to make sure everything was done correctly, nothing was missed. If all requirements are missed, boom, you get the certificate, you get the certification, the assessment report, and the certificate posted. You now have that product on the SAEL website. The FMETA report will stay private with the manufacturer, and the end users can always ask for the safety manual and the FMETA report if they do need more information when they do start setting up their systems. So that was kind of in a nutshell what we do for product certification. And I did talk about this briefly, but a good certification scheme, we detect the design faults in electronic, software, mechanical designs. We design the test processes that must be established by a manufacturer to reduce or detect design faults for all safety critical devices. And finally, these activities have been shown to improve the reliability and the safety of instrumentation devices, and that's very important. And then I got these two final slides here. So let's talk to the end users. What does this mean for you? Well, having a product certified has statistically shown that you will now start seeing less spurious trips. To me, that's huge. It depends on what you put this system in. Maybe you don't need or need even worry about spurious trips, but most people do. You're going to now have an increased safety. You have less field failures because you now have a product that's been looked through with a fine-tooth comb. That system is now going to become more robust. And I always like to say, and I make this important, that third-party review, there's nothing like having a non-biased review of a product that you're going to go buy that someone outside of the company you want to buy from, because that company thinks that their product is the best. Everyone thinks their product is the best. That's why you make that product. But now you have somebody on the outside looking in at them, trying to figure out, okay, is it the best? And then they're going to go down to the single nut or bolt. They're going to find all the issues that they possibly could find and help you out so when you do have this product, it's as robust as it can be, and you're going to see a reduced failures. So what does it mean for the manufacturer? Okay, now the end users are happy because they see the product certification. What about for manufacturers? Why would manufacturers get their product certified? Well, the first thing is you now have somebody coming in, right, that's outside your company, help you figure out, okay, was this designed correctly? Are we going to find faults in this design? You're going to now have a lower life cycle cost, okay, which is very important. The next thing is, because you went through this rigor, you paid a little bit more money up front, you now will have this ability to have an increased market, increased sales. A lot of manufacturers, they have a non-certified product and a certified product. The certified product will cost a little bit more. Why? Because they went through the due diligence of getting that product certified. So now you will have that capability. The next thing we've seen is an increased, well, obviously you have an increase initially, right? So this cost, let's say, is X. Well, because you spent X on the certification, you now have a lower risk and an increased savings over the long term. How? Because now, by statistics, it now shows that a certified product will fail less in the field, so you're going to get less returns, unless, of course, the end user uses your product incorrectly, right? Because you can't help that. You're going to have to worry less about recalls. It's going to be, it's going to have a lower risk of having any kind of recall, redesigns, less rework, so reduce failures at the manufacturing site and in the field. And so these are just different things to think about that we here at Exida didn't think at first, but now after working and doing this for so long, we're now starting to see all these different benefits that people can have when they certify a product. And the one thing I do want to say, because we got this question this morning, is they said, hey, let's just certify everything. That is not the right answer. We do not want people thinking that SIL certification is the way to go on everything. If it doesn't have a safety function, there's no need to get it certified. And so there's been many inquiries that we get. We probably get a couple a week where they want to certify just the craziest things, and because there's no safety function, there's no reason to do it. So we just decline people if it doesn't make sense. So if you have a product, this morning I think we got a list of like 5 or 10. They just want to say, hey, can we certify these things? And as we went through it, no, you're not looking for it. But what you do want to look for are these other things, and we'll try and help them with knowing what are the other items that they should go and to look at if it can't get certified. Okay, so now I finished that portion. I hope that information was helpful. Let me go and see if I can't find these questions. One moment here. Great. Excellent. All right. The first question I have is, why is the audit set to 3 years where TUV has a 5-year audit? This is a great question, and the only reason there is per the scheme, right? When we first got started, we were, well, I wasn't, but when we first got started, TUV was the first certifying body out there, okay? And when they first started, they said, let's do it every 5 years, okay? There was no real science behind it. That's just what they felt. As the industry was changing, they felt every 5 years was acceptable so that they can find, make sure they can stay up to speed, right? They're not accredited, which is okay, but that's what they wanted to do. When Exida got started, our founders, Reiner Faller and Dr. William Goebel, decided, hey, look, 5 years is fine. However, due to this advisory board of the end users were the ones pushing, hey, look, 5 years is okay, but we would rather 3 years. It happened at the very beginning. It's stuck. So every 3 years now, what Exida will do is we stay true to it because we know technology changes faster than every 5 years. When we were looking at it, it looked like that every 3 years was probably like that sweet spot when we felt people need to be evaluated. There's nothing more to it. It's not in any kind of standard, but part of the Exida scheme, we've decided that 3 years from the beginning was the right amount of time. Now, if the end user come back to us and say, hey, look, we know you're 3 years. We don't care. You can be 5. You can be 6 years. We have the capability to change that. We just have to document why we're changing it. If we don't see technology changing or improving very fast, there's no need. All right. Some people get 3 years. Some people get evaluated every 1 year. If there's a process that's not too, so let's say people can hit certification, and some people can barely hit certification. You must meet every single requirement. However, if someone barely hits certification, we actually don't grant them a 3-year. We grant them a 1 year. And that 1 year is because, look, you did make certification, great job, but there are some areas that we feel you can get better. And so that we'll actually do a 1 year, we'll reevaluate, make sure that they meet those things, and then they go to a 3-year. So I hope that answers your question. That was a very good question. Thank you very much. All right, the next question I have here. Why do manufacturers who don't have IEC 61508 certs, do they have bad quality? No, not necessarily. Just because someone's not certified, it does not mean that their quality is bad. However, the one thing I do want to say is that their quality is going to be unknown, okay? So this is an unknown compared to those who have like an Exida certification. It's kind of like a body that's not audited by anybody else, right? So say a certified body that's not accredited, who's to say that what they say is accurate? Who's to say that what they're saying is to a standard? They have nobody telling them what they should or shouldn't do. That's why Exida chose to go the accreditation route. That's why we spend thousands of dollars for these audits and to be certified and to stay up to the newest standards, because we see the value in it. We know that we can always be better, and that's why we wanted to be audited. That's why we have the advisory board, so everybody can tell us how to improve. And as you see, as Exida grows, more and more requirements we're going to have to meet. The standards are getting harder for us. However, it makes us a stronger certifying body to ultimately help that end user in the long run. So why does Exida do surveillance audits and others don't? Well, that's kind of a similar question to the first one I had. Well, studies and from our Exida experience, we've shown that design errors basically can be introduced when design changes and enhancements are made. Okay, so yeah, you can go through, you can get your product certified, and that could be it. But who's to say, say management changes or personnel change as this product was certified, all of a sudden all these hands change, people get promoted, people leave the company, people win the lottery, right? And they're no longer with this company, or they're in a different division. Who's to say that next guy who might not know functional safety makes a change thinking, oh yeah, it makes it easier. Why in the world did we push this? Why did we make this button right here? Let's just bypass that. Well, when these enhancements or design changes happen, you want to make sure that they're still compliant. So what happens is, because we have these surveillance audits, we can now ask those questions. We can look at the field failure return information. We can find out if this new design affects anything that was previously certified. And that's the main reason for it. We do it, like I said, every 3 years. Other agencies do it every 5, and some don't do it at all. They give you the piece of paper and they say, you're great, go ahead, see you later. But we don't do that, and that's solely because our advisory board has informed us this is what we want. And from our experience, we're noticing it helping out a lot. And I think the biggest thing that we're noticing is when personnel change and changes happen, that's usually when we see, hey, they bypassed this and they shouldn't have, and we're able to help them and tell them why they did what they did. Next question I have here. From your failure rates, you speak of the FMEDA. How do you know those failure rates are accurate? That's a very good question. This is actually an excellent question, one that's asked a lot. And so what we have is we've developed something called the failure mode effect diagnostic analysis. We go through and we break this component, this device, this element down to the nut, the bolt, and we put failures associated to each part. We put it all back together, and you get this total failure rate number. What then happens is we look at the database, right? And anyone that has Excellentia, they can do this as well, but they can put in their system and determine what the failure rate should be. We can take a FMEDA with Excellentia, and there's one more piece, and the proven use analysis, and we can look and we can put a comparison to see, okay, are you in range where the failure rate should be? And we can, because we have so many operating hours of field returns and of all this shipment and warranty information, we can now see, okay, where is it supposed to be? Where's the range? And depending on their site safety index, if they're great, then we know that their failure rate should be lower. If their site safety index isn't as good, they're not really following the procedures as well, then we know they should have a higher failure rate. And because of all these hours that we have, we're able to do that. And Exida is the only one with this type of database because we started at the beginning, and this is nothing that we could have done overnight. But it's growing more and more. We're getting more accurate. We challenge IRETA, we challenge NEMOR, we challenge all the Dow, we'll challenge everybody out there with their different failure rates to find out why and how they have their failure rates, how do they publish what they do, and these are some fun conversations. And so far we're doing a fantastic job. We're right there with Dow, right there with IRETA once you break everything down, so we feel very confident with the failure rates that we have and what we're publicizing. Great question. Okay, that's all the questions. What I will do, thank you so much everyone for attending today's webinar. I'll go ahead and take the questions from the first session, the questions from the second session. I'll put them together. I'll send you a document with all the answers to them. And I do want to thank everyone for taking their time out of their busy schedule to listen to this. You will get the slides for this presentation. This will be recorded, so we'll throw it on our YouTube channel as well. So thank you. Have a great rest of the day. If you have more questions, my contact information is below. Feel free to email me, and I'll get to you as soon as possible. Thank you so much. Have a great day. Take care for now.